Okay, hello guys. Our goal for today is to understand how we do security research and vector analysis and how you can do it yourself. And we also showcase a pretty cool vulnerability research we've conducted very recently. So I hope you have fun and hold me up to it. So one of the most common terms that we've seen that is rising more and more in popularity is the XIoT, Extended Internet of Things. And sometimes it's hard to understand what exactly does this term mean, because it is an umbrella term. Because when I'm saying XIoT, I could be meaning a wide range of devices. And today we're going to showcase how we can pwn and basically find exploits in these devices. And the XIoT range is pretty huge. I mean, who here doesn't have a smart home? Who here doesn't have a smart thermostat, cannot control his AC or shades remotely? And of course, when we're talking about OT and SCADA networks, more and more are starting to be connected and internet connected, and maybe even internet facing, meaning they are available from the public internet. Basically, the XIoT means the center point, the convergence point between the OT, IT, IoT, IOMT, Internet of Medical Things. That's the certain center point between all of those realms. And if I had to define what is an XIoT device, it is an internet-facing, internet-capable device that was custom-built to fulfill one or two purposes. It could be a smart thermostat. It could be a car that could be controlled remotely. It is one specific device that does one specific purpose. However, we have thousands and millions and billions of those devices, and we see a sharp rise in more and more devices, and somehow you need to control them. And that's exactly what our research will showcase, because we don't want to go to every one of my sites whenever I have a problem with my device. I don't want to go all around the States just to do a firmware upgrade. I want to be able to control them remotely through the cloud, from my home, my office, anywhere, one centralized point to be able to control, view device configuration, status, etc. For example, we see more and more rise in this kind of software, like Claroty, which is an OT vendor doing a lot of PLC applications. And one of their programs in the portfolio is the automation server, which is a cloud application that allows you to connect your PLCs, and then you can view your status, view tags, do some project upload, download, etc., from the cloud in the comfort of your office. But what happens if it's not hyper-connected? I mean, I don't see vending machines with an internet port being connected all the time. Well, that's when another IoT device, XIoT device, is introduced, and this will be the focus of our research today, a 4G router. And this router acts as a gateway, as an internet gateway, which through it, I'm going to navigate all of my devices and make them internet accessible. However, this is also an XIoT device, and this also has attack vectors. And today, we're going to showcase to you how you can pwn those devices and understand the architecture in order to find architecture flaws and basically achieve full control over said devices and everything they hide behind. So over the years, we've done a lot of research, ranging from routers to intercoms, OT devices, SCADA, access point, and backhauling device. However, today we're going to showcase one research in particular, being Connected.io. What is Connected.io? It is a 4G router manufacturer that supplies 4G routers as acting as internet gateway for many companies. It could be used for your point of sale, meaning connect on your registers. It could be used for remote site connectivity. Basically, all it does is connect your devices to the internet. And of course, like any good XIoT device, it needs to be controlled remotely from the internet as well. So Connected.io offers a cloud platform allowing you to control your devices remotely, allowing you to see your device status, see their alerts and events, and do some configuration changes like network configuration changes, etc. Now, our goal here, and whenever we do a vulnerability research, is to understand the architecture. How does the device communicate with the cloud, communicate with the user? And what kind of functionality is there to be? Because each functionality could be used to find exploits, vulnerabilities, and basically get control over devices. And we can do this in two ways, which we always do. It is either a top-down or bottom-up, meaning I can go to the cloud endpoint, in this case, Connected.io Cloud, and simply register for a new account. And then I do some web vulnerability research, looking for vulnerabilities like an SQL injection, OS command injection. However, it is very black box in nature. The other way to do it, and this is our favorite way, is doing the bottom-up, meaning I go to the device, I download the device firmware, which you can see here, and start analyzing it. When we download Connect.io's device firmware, we realize that it is a very big binary blob containing all the stuff the device needs. And using some very well-known reverse engineering tools and basically research tools like Beanwalk, we were able to extract the firmware and find out what is inside. And inside was two main things, the first being an OS. I mean, every device needs an OS, in this case, OpenWRT, which is a very well-known Linux distribution for network devices. And the second thing is the file system, meaning what is on the actual devices. And using these files, we try and understand what the device actually runs and what kind of vulnerabilities could there be in the said device. However, before we can understand what the device does, we first need to understand what is the architecture. We need to take a step back and understand the bigger group, the bigger picture. You see, at any given point, a lot of XIoT devices are connected to the cloud. However, at some point, a user buys a new device and connects it to the cloud in the first time. And the first thing most devices do is try to reach to the internet. And whenever it does, it needs to identify itself somehow. However, luckily, devices have some hardware identification, being a serial number embedded on the device chip in the manufacturing process, being a MAC address, which should be unique for any device. And using this identification, the device sends it to the cloud. And most of the time, the cloud platform also is made by the vendor, meaning they have access to those hardware identification, and they can validate it and make sure it is indeed a valid, legitimate device. Whenever it does so, the cloud accepts the new connection and says, yeah, that's a valid device. I'm going to connect it, and the tunnel is established, meaning the device is now able to be paired to the cloud and claimed by users. Then the user comes and wants to access their device. I mean, I just bought a new device. I want to access it. I need to do it. So I go to the cloud, and I want to access my device. However, somehow, once again, I need to identify it. Sadly, I don't have a chip on me, so I can't just read something from a chip like the device serial number. And that's when I look at the back of my device, and I see usually there's a label. And the label contains the device serial number, MAC address, etc. So I take this identification, put it in the cloud, and now my device is claimed, and I am the owner of this device, and I'm able to control it remotely through the cloud. Cool. So that's the architecture. However, let's try and understand how does this magic actually happen? I mean, how does this in specific happens? How does the device connects to the cloud? You see, somehow the device needs to establish a secure channel between the cloud to be able to communicate back and forth, send commands, send status reports, etc. And from our experience over the years, we've researched quite a lot, and we know that a lot of vendors choose many different protocols, stacks as the backend to basically start this communication channel. For example, we have MQTT, which we're going to go into a little bit in depth in a little bit, so stay tuned. But we also see a lot of WebSocket that is used to initiate a socket back and forth communication, binary communication, using it over HTTP or HTTPS. However, vendors can choose to implement any protocol they choose as long as the channel is created. And when the channel is created, this device starts communicating with the cloud, and it is now able to control it through the cloud. Now, let's try and understand what is the attack vectors. You see, I'm a vulnerability researcher. My job is to understand where can I find vulnerabilities. And I think the most important part in any vulnerability research is trying to analyze the attack vector. Where could there be exploits? Where could there be problems? Where could there be authentication bypasses? Where could there be misconfigurations, etc.? And when I look at the XIoT cloud, how can a cloud be? If that's the architecture, that's actually where there could be vulnerabilities, which I know it's pretty much everywhere, but sadly that's how it is in real-life scenarios. I could have just put one big red arrow pointing to the whole thing. But let's try and understand how can we understand, and by the way, it's not only relevant for an attacker, it is also very relevant for like CISO or any IT guy to understand what is the attack vector on their devices. So let's try and go over what kind of vulnerabilities are there and what kind of attacks can happen when we're talking about this specific generic architecture. So when we're talking about cloud platforms, one of the most interesting things for me as an attacker is performing cloud takeover, meaning I need to be able to control the cloud infrastructure itself in order to escalate my privilege even further. It is especially relevant when we're talking about multi-tenant situations. I mean, whenever I go to a SaaS cloud, there's a big question: what are the shared resources? Am I using the same web server that any other organization uses? Maybe shared databases, maybe shared SSOs. There are a lot of options, and usually when we're talking about cloud deployment, we're talking about shared resources, multi-tenant versus single-tenant. And my main goal as an attacker is to escape my tenancy, meaning being able to reach other tenants' information, other tenants' infrastructure, etc. My job is to attack the cloud itself, and that way being able to escape my way to other organizations' information. And when we're talking about this kind of attack vector, we're talking about usually web vulnerabilities, meaning being able to execute code, actual code, OS commands on the cloud infrastructure itself. And this is actually quite a common mistake. I mean, when we are talking about a web application, usually we see some kinds of OS command being executed, and if I, as an attacker, can inject some part into this OS command, I can easily gain remote code execution. For example, we have undisclosed, the vulnerability is disclosed, but the company is not, a cloud platform that allowed us to perform a curl command, fetching some information from our devices, but by simply providing, instead of an IP address, an OS command, we were able to achieve code execution and then be able to control the cloud infrastructure. Well, sometimes when we're talking about multi-tenant situations, what's more interesting than the infrastructure itself is the information. If I share some information and an attacker can get my organization information, it could be critical. I don't need to actually pawn devices. If I can just get all the information from them, sometimes it's even more interesting, especially when we're talking about medical situations or even OT and critical stuff. My goal here is to leak sensitive information, which could be done using a lot of different vulnerabilities that we've seen over the years. For example, here we have an open AWS bucket containing sensitive customers' information, like pictures, like configurations, etc. Or here, for example, we have a very cool research we've conducted that allowed us to view physical location of antennas and see where exactly they are located and where their beams are located, meaning we are now able to understand the range completely. However, that's pretty cool, but sometimes I want to reach the device. I mean, maybe I can reach the actual physical device from the cloud, allowing me to execute code on it, and then I can basically break NAT protection. I can get into a company's backdoor and internal networks, and that way I can maybe leverage and move laterally in other ways. And this is usually done through understanding what kind of functionality does the cloud offer and trying to find vulnerability in the cloud user device communications. Maybe I can do an OS command injection, which we're going to see in a little while, and maybe I can do a message injection, injecting a new command entirely from an old message. Lastly, sometimes the cloud simply trusts the devices, meaning I can simply impersonate a device and saying, yeah, I'm this company's device, send arbitrary data, and then I can mess up with their product, allowing me to fabricate metrics, allowing me to raise alarms, raise events, and basically create a denial-of-service attack on actual other organizations. And using this technique, we can even take it a step further, allowing me to actually attack back the users, meaning I impersonate a device, and somehow I invoke a vulnerability back to the user. Well, for example, we have here an XSS vulnerability we found, where through device impersonation, we were able to supply malicious JavaScript code, which whenever the client, the actual user of this device, connects to the cloud platform, it will execute arbitrary JavaScript code, allowing me to fully control and execute JavaScript code in his browser. And of course, an open redirect vulnerability when I simply can take control over the entire session, browser session. Basically, now that we understand what are the attack vectors, we can now go back into our research into connected I/O and see how it actually happens. That's cool understanding where should we look, but let's see how it can actually be exploited. So from looking at the firmware of connected I/Os, once again, the 4G routers firmware, we discovered this very cute configuration script that actually dictates an IP address for an MQTT broker, which, like we've said before, could be used for cloud communication. And what's even more funny, a connection ID and password, meaning a username and password for this connection. You see, when we're talking about MQTT, one of the rising stars in communication protocols, we're talking about a broker, meaning I, as a client, connect to a broker, which simply distributes the messages to their correct attendees. This protocol allows me to subscribe to a topic being a named channel, and then whenever a message is sent to this named channel, I will receive the message. And of course, we have a lot of security configurations like encryption, authentication, etc. And looking back, we saw that we have the strings for the client authentication embedded in the actual firmware, meaning this is not a live image of a device. This is embedded into the firmware, and it is the same for all devices. Meaning using these credentials, I can identify to the broker that I am any device, and he cannot distinguish between me and another device. Meaning I am now able to authenticate as a legitimate device, and not just one device, any devices. So we started reverse engineering the main cloud binaries from the firmware and trying to understand what is the actual topic name, topic channels, and how does the cloud actually communicate with the devices. And we discovered 3 topics. Once again, topics are named channel in MQTT, basically a communication channel. The first being the status topic. Now, this topic was used by devices to send basic status reports like keep alive, heartbeats, and actual status messages like, hey, this is me, this is my configuration, and this is whoever is connected to me. And when we tried subscribing to this topic, it actually worked. And we were bombarded with thousands and tens of thousands of messages every single second from all the devices around the world, allowing us to basically achieve full wiretap capabilities from all the connected devices to the cloud, no matter where they are. And inside those status reports, we saw 3 main things. The first being the device configuration. For example, here we have an SSID, a Wi-Fi name, including Wi-Fi password, which you could use for physical identification. However, we saw another interesting thing, which were actual physical identification. We saw that in any message, the device IMEI was sent, allowing us to actually exfiltrate physical identification from the device. Also, we see a MAC address, which could be used to claim the device, and in some cases, even serials, meaning just from hearing the messages, wiretapping on the messages, I am now able to claim any device and fully control it through the cloud legitimately. Then we try to understand how does the cloud send commands to devices. And that's when we discovered these 2 named topics, which that's not a typo, it's on the developer's typo, missing a slash, that's not me, that's them. And we discovered 2 topics, the DR and DS, device receive and device send. Through the device receive topic, the cloud sent commands to the device, and through the device send, it sent the responses. And basically, we see that the IMEI is used as an identification, meaning if the cloud wants to send a message to one specific device, it sends it to its topic name, specifying the device IMEI in the topic name. Well, that's cool, but from the vulnerabilities before, we now have all the devices IMEI because they reported it in the status report, allowing us to compile a huge list of all devices IMEIs and all devices topic names. And whenever we subscribe to this topic, we saw the entire commands the cloud sent to them. Well, that's cool, but let's see what kind of commands the cloud can actually send to the device. And that's when we started reverse engineering the protocol. How does the cloud send commands to the device? We reached a really cool binary called XIoT client. And in it, we reverse engineered the protocol. And the protocol was an ASCII protocol constructed from two main parts, an opcode saying what kind of message is this, and parameters. For example, the opcode 1125, which is actually a string 1125, says to the device, get interface status, meaning show me what kind of network interfaces do you have. The opcode 1100 means do a firmware upgrade, which in the second parameter, I give a signed firmware, and the device simply upgrades to the newest version. However, when we looked at what kind of commands there is, one command caught our eyes, 1116, which is bash command? Yeah, it actually is. This command allowed me to execute arbitrary code, meaning simply supply a string, and it will execute it. Pretty neat idea. Command execution as a service. That's a cool feature. If there are any product managers, think about implementing it. That's cool for me, at least. It basically takes the second argument and executes it, sending it the response. And we thought to ourselves, yeah, that could be a legitimate feature. If the cloud can send commands to the device, it could be legitimate. But maybe we can send commands to other devices, because once again, we have credentials. So we constructed our payload, which looked like this, command 1116, and a simple bash command, for this case, touch. And it actually worked. We pwned our device, allowing us to execute OS commands over the MQTT topics. Now, since we had all the topics, not only our device was vulnerable, but instead all cloud-connected devices. And that's actually pretty crazy, because from our analysis, there are a few tens of thousands of devices connected to the internet, connected to this MQTT broker at any given moment. Furthermore, when we realize what these devices are used for, to connect other internal networks to the internet, we understand that we are not only pwning these tens of thousands of devices, but instead, we reach tens of thousands of internal networks. We reach tens of thousands of other organizations that are using this device for point of sale, for remote site connectivity. We now have access to their NAT network. We now have access to the more sensitive parts of the networks. Now, we reported these vulnerabilities to Connected.io, and they were very professional and actually fixed everything. And we can now say that every single device that is connected to the MQTT broker is now patched and is both no longer vulnerable to the vulnerabilities like this, and also does not use the hard-coded credentials anymore. So we help protect tens of thousands of companies, maybe thousands. OK, that was a pretty cool experience, but let's try and understand what are the key takeaways. I mean, yeah, cool, that's one vulnerability that we found, a few vulnerabilities, one research we've conducted. However, it's not just one. We do it all the time, and we see common mistakes. And we analyze them and try to understand what is the bigger picture, what is the architecture mistakes. Because you see, XIoT is here. Every single organization has a few hundreds, maybe even more, of XIoT devices connected to its networks all the time. And usually, those devices are like a black box. I don't know what's running in them. I don't know what they are connected to. They are there, but I don't have control over there. And it's really hard to basically know what's in your networks. We as a community need to be better educated and understand better what are the risks that are coming from these devices connecting to a cloud application, to a beacon, sometimes even without our consent, because that's the first thing they do during the initialization process. I don't need to claim them. They are already connected and paired up to the cloud. We need to understand that these devices are here and to understand that they are an attack vector on the networks, and we need to better protect them. Usually, we see a lot of problems in device authentication, and we believe that usually the most common pair for device identification are serial number and MAC, and that's just not strong enough. We're talking about 3 bytes of randomness. That's not enough. We need to somehow be able to track what are the clouds that we are connected to and could be used as a leverage. Thank you very much. Uh, If there are any questions, feel free to come to the mics, which I think are there and there. And I'll be happy to answer you.
Yeah. So I have one question. I used to work for a cellular router vendor, not Connected.io, but I'm wondering if you've seen other cloud management platforms, other methods of pairing and communication, and if you've seen, I guess, any, from your perspective, best practices or better practices in terms of how that connection, how the registration process is handled.
I think, yeah, Connected.io is not the only vulnerability research we've conducted. We've conducted several other vulnerability research on either 4G routers and cellular networks, and we've seen many cloud platforms. I think the main best practice is to have stronger identification and stronger isolation. I mean, if we're looking back, in this case and in many cases, the only identification for devices are simply MAC address, which is only 3 bytes, and serial number, which is sequential. That's not strong identification. We're talking about maybe tops 1 million different permutations for each device, and that's pretty weak. I think if you're doing a cellular cloud platform, you need to have stronger device identification and also better device isolation, because one device should not be able to talk to another device. Each device should have their own certificates, their own communication keys, and they should be totally isolated, meaning the device can only talk to the cloud. It should not talk to other devices. And same goes for the web platform.
So just as a follow-up, I've seen the platform you looked at used MQTT. I think Autorio presented some research yesterday where the platform was also MQTT. Have you seen other platforms or architectures where people can use them off the shelf to have a better starting point for device management? Or is it more a matter of using something like MQTT better?
MQTT is just like the protocol. MQTT has the ability to be secure. I mean, the biggest, like Amazon, Azure uses MQTT, and they use it successfully. The key is to enable the security measurements like unique device authentication, like device isolation, meaning device should not be able to write messages to other devices' topics. MQTT is not a problem. I mean, the same can go for WebSocket, for example. The only thing you need to do is to understand the attack vector, meaning one device being able to communicate to another, and then configure your broker to act accordingly. So I think MQTT is a good protocol. It just should be used securely, meaning do proper permissions on channels or topics.
Thank you.
Thank you.
Hey, thank you for your talk. It was great. I really enjoyed that. Always happy to hear about MQTT because I took a look at it a few years ago. And a couple of thoughts there, or questions actually. So the first thing is that when you try to connect to an MQTT server, it does give you an authentication code, right? That sort of tells you if TLS is enabled, if password authentication is enabled, and those type of things. So a few years ago when I looked at it on Shodan, I found that about 70% of these servers would not have any authentication enabled, right? And pretty much allow you to connect to any topic. So is that still the case?
Yeah, like you said, MQTT is, you are able to configure what kind of authentication and encryption you use. You are able to use username password, which I think is weaker. You can even use certificates, including client certificates, which I think is the way to go. Sadly, I can tell you that a lot of MQTTs are still indeed basically open, allowing any device to connect to them without any authentication. Or as we see, like if you are using, for example, authentication or even certificates, if they are hard-coded, it doesn't matter. Because once I get the certificate, I am now able to authenticate, and that's OK. And that's really bad, because I'm now able to inject messages, read messages, etc. So sadly, yeah, we still see a lot of hard-coded credentials. We see a lot of bad configurations, like unencrypted, like unauthenticated, etc. Yeah.
Could you also comment a little bit about the use of wildcards? Because you can use wildcards to connect to all topics, right? I mean, it's a great convenience when you have constrained devices connecting and you don't want to bother about having strong policies on the broker. But Yeah, that's another thing about MQTT, right?
Yeah, exactly. MQTT, you are able to subscribe to wildcard topics, meaning I subscribe to any topics in this, like basically regular expression, like anything that comes after this, allow me to subscribe. That's also a very bad practice because you should be able to know the topic name. If you're using like identification in the topic name, like an IMEI, we should not be able to subscribe to all the topics.
Thank you.
Thank you very much, guys. It was a pleasure.